This is 5.1 key features. We're doing domain, range, intercept, symmetry, and end behavior. We're going to define all of those and then move on to examples. So I'm going to write those definitions and then you can pause and write them as well. Okay, here are the definitions. You can pause and write those down or follow along. All right, domain is all possible x values left to right. Range is all possible y values bottom to top. X-intercepts are where the graph touches or crosses the x-axis and is the point x, 0. Y-intercept is where the graph touches or crosses the y-axis and it's a 0 y point. Symmetry on the y-axis is your even functions, so you have x, y, and then if you put a negative in for x, you'll get the same y value out. Examples would be your x squared or your absolute value of x. Next is our odd symmetry, which is our origin symmetry at 0, 0. And that means if you have x, y, and you put in a negative x, you'll get the same y, but it changes sign, so it'd be a negative y. Examples of that would be x to the third, x, and cube root of x. Neither symmetry means there's no matching points, or the graph moved away from the y-axis or origin. And then end behavior, we did that before, so you should remember it's the limit as x approaches negative infinity, f of x equals, so that's the left side. And then the right side is the limit as x approaches infinity, f of x equals. Now remember, f of x is the same as y, so as y is approaching, you're going to have your answer after. So the rest of it is your limit notation. That should be the same for everything. And then your answers will be after the equal to sign or the arrow, depending on what your assignment has. Let's look at our first example. We're going to be graphing these using our transformations. This has a 1/2 in front, so that's a vertical shrink of 1/2. And then nothing inside with x, and then outside that -2 is going to be a down 2. So that means our new center point is going to be at 0, -2. And then we have -1 and 1 that we'll plug in, and that means we're going to be timesing them by 1/2 and subtracting 2 to get our new values. So 1 squared is 1, 1 times 1/2, so you'd have 1/2 minus 2, which makes a -3/2. Because this becomes 4/2, so 1 minus 4 is -3. So -3/2, and then it is a quadratic, so that means that these are matching. And then if we plugged in a 2, 2 squared is 4. 4 times 1/2 is going to be 2, so 2 minus 2 is going to be 0. So we're just plugging in those points. So 1/2, 2 squared minus 2. So 4 divided by 2 minus 2, that's how we get that 0. Same if you plug in a -2, that squared is going to make it positive, so it's also going to be 4/2 minus 2, which is 0. So you're just plugging in those points there. So if we were to plot our points here, and then it's our u-shaped function, and then if we put in 4, we're going to get 6. And 4 on this side, 6. So it makes it a bigger U shape. All right, for our domain, so all possible x values. So we have arrows on both ends, so that means it's -infinity to infinity. Range is bottom to top, so the bottom of our graph is -2 on the y, because remember it's our y values, and then pointing up and up, so that's infinity for the end. X-intercept is where we touch our cross. We touch our cross at that 2 and -2. -2, 0, and 2, 0. Our y-intercept is that -2, so it's going to be 0, -2. Symmetry, we are on the y-axis, and we do have those matching points. Look how the points on the y-axis are all the same. So we would have even or y-axis symmetry. All right, and behavior, so limit as x approaches -infinity, f of x equals, and then the right side. All right, so the left and right side, they're both pointing up and up, which is infinity, so our answer is infinity for both. All right, next one. Transformations, we have a negative out front, so that's a reflect on x-axis. To make sure this page doesn't move. And then -2, that's going to be a right 2, plus 3 on the outside, up 3. Right 2 up 3. So our new center is at 2, 3. And then we have a reflect. So that means we're going to go down 1 over 1 because it is our absolute value. It is that linear function on both sides. I want to make sure I cross at the right points. There we go. All right. Domain. Well, if you wanted to do points, so if we plugged in, let's see, on this side we have 1 and 0, and then on this side we have 3 and 4. So if we plugged in a 1, 1 minus 2 is -1. Change it to a positive. Then we have -1 plus 3, which is 2. And same on that side. And then 4 minus 2 is 2. Make it a negative. 3 minus 2 is going to be 1. And then if we went farther, 5 and 0 and -1 and 0. And you'll see those are our crossing points for our x-intercepts. Domain, we have arrows on both ends, so -infinity to infinity. Also, we're not dividing by x, we're not square rooting x, so we don't have those restrictions. Range bottom to top, this time our arrows are coming from the bottom. Remember, the bottom of our graph is -infinity for y, so -infinity, and we're stopping at that high point, which is at 3, and it's going to be a bracket because it's part of our graph. X-intercepts, from plugging in points or from looking at where it crosses, is going to be 5, 0, and -1, 0. Our y-intercept, if you follow your graph down, it's going to be that 0, 1. And you can look at that from your table of values as well. Symmetry, we do have matching points, but it moved away from the y-axis, so our x's aren't the same. Notice how they're all different. So that's going to be a neither for your symmetry. End behavior. So you write out your notation for the right and the left, or left and the right. Just make sure you have both of them. We're pointing down and down, so pointing towards that -infinity. So it's going to be -infinity for both. All right, and then that is it for these notes. And then we're also going to be doing graphs where we follow along and fill in those pieces. So that's going to be in that video number 2, where it's all combined together. So make sure you go to that other video to get the rest of the notes for this section.